we're out here today to talk projectile motion. And that's the flight of bodies through the air. Really important though, that there's a lot of things that fly through the air that are not projectiles. And that's because when we talk about projectiles, we're talking about bodies that have just one force acting on them, that's gravity. So if there's any other force acting on your body, then it's not a projectile. For instance, an aeroplane is not a projectile. Yes, it's got gravity acting on it, but it also has the lift force from the wings acting on it. Same for a bird, same for a rocket. However, something like a basketball flying through the air, we assume that the air resistance is negligible on it, and that lets us solve problems about it 99% correctly by assuming that the only force acting is gravity. The way we go about solving all projectile motion problems is that we split its velocity into two components and we treat them completely separately. Now the reason we do that is because the horizontal component, the one that's moving horizontally, ignoring the fact that whatever our thing is, our basketball, is going up and down, forget about the going up and down, only think about its horizontal motion, that's constant, because we're going to assume that air resistance is negligible. Now that means that we're allowed to use speed equals distance over time. That band devil equation, because velocity is constant. However, when we come to do the vertical component, we know that that vertical component, forgetting about how our basketball is moving horizontally, we don't care if it's been thrown up in the air or across from the three-point line, that vertical component is being constantly accelerated downwards by gravity. And so we're going to solve that vertical component using kinematic equations, which allow us to solve for gravity. And so really the only other thing that we need to know about this projectile motion is the shape of the path. And the shape of the path is like an x-squared graph in mathematics, but flipped the other way up. It's a parabolic motion, which means that if you start somewhere horizontal and you finish somewhere horizontal, it's going to be completely symmetrical. And that symmetry allows us to simplify our problems. However, if you are throwing your basketball by standing on a stool and throwing it to the ground, then it's no longer symmetrical because the starting height and finishing height are different. So we need to watch out for those sorts of things. Let's have a go at an example. So, the three main types of things that we might want to try and find in a projectile motion problem are the height, like the maximum height that our object reaches, the time of flight, how long is it in the air for, and the range. The range means the horizontal distance travelled. It's important that we know range means horizontal distance in this context. And we're going to have an example like this basketball that magically takes off from the ground, 15 meters per second, angle of 30 degrees. The first thing we have to do is split that velocity into two components. So you should pause this and make sure that you can do that with your trigonometry. This is revision. So, quick little bit of calculation using trigonometry. Using sine to find the far side, we should have got 7.5. Cosine to find the adjacent side, we should have got 13 meters per second. Now, height. First of all, think about what you know and choose a kinematic equation to solve for height. Pause the video and have a go, otherwise I'm just going to do it for you. first of all, for that height, we're going to use the equation VF squared equals VI squared plus 2AD. And the reason that works is because we know that at the top of its parabolic path, that ball is going to momentarily pause, thinking only about its vertical motion. So solving for height, we're just thinking about the ball going up and down. And we know at their maximum height, it's going to stop, and so the VF is 0 when the height is maximum. The VI we know is 7.5. Negative 9.8. It's very important that we use negative, because when our working happened, we got a minus 7.5 squared, and so the negative on the top and the negative on the bottom have to cancel so that our height is positive, so that it's up. Should have got only 2.87 meters, about the height of a house. Next, time of flight. Now there's a trick to this. The easiest way of doing this is to break the flight in half, and you're just going to calculate the time to get to the top of the flight. So choose a kinematic equation, pause the video, and do that now. So, with the time of flight, once again, we're only going to think about the vertical component of the motion, and we are going to once again use that idea that the ball, or whatever the object is, pauses momentarily at the top of its flight. And so the VF, once again, is going to be 0. Use that VF to find the equation. VF equals VI plus AT. Rearranged to make it T is VF minus VI over A. Plug some numbers in and you should get 0.77. And then we can use symmetry to know that because it's horizontal ground, the time up is the same as the time down. So 2 lots of 0.77 gives us 1.54 seconds to go up and down. We can only do this because it's a symmetrical path. If it was not symmetrical, we'd calculate the time up, and then we'd use a different equation to calculate the time down again. Finally, the range. That means the horizontal distance travelled, and the good news is that because there's no acceleration horizontally, we can use speed equals distance over time, the equation of the devil. Pause the video, make sure you can get the same range that I do. So you should have got 20.02 meters. And that's really, really easy. The horizontal velocity is 13. We know that how long is it moving at that horizontal velocity for is the total time of flight, 1.54 seconds. Because everything's constant velocity, no acceleration, we can just go back to very basic mathematics. Distance is speed times time, and 13 times 1.54 should get 20.02. You could have used a kinematic equation and put in acceleration is 0, and you would have got the same answer. Nice little thing to check. So if ever you're not sure, use the kinematic equation, because it will still give you the right answer. Even if acceleration is 0, it will still work. They always work.